Hello friends. Welcome to my YouTube channel. This is the last session in Apspdcl Assistant Engineer Electrical Solutions 2014. Friends, thank you for views and watching my videos and comments. So the question on the screen is: a synchronous motor has Xs is equal to 1.0 per unit. It operates at V is equal to 1.0 per unit. The per unit values of current when E is equal to 0.5 per unit at an angle 0 degrees will be. So the general formula for this solution is I is equal to V minus E by X. So this is equal to 1.0 minus 0.5 divided by, so X is nothing but J here. So J into this value is 1.0. This is equal to 0.5 divided by 1 at an angle 90 degrees. This is equal to 0.5 at an angle minus 90 degrees is nothing but minus J 0.5. But in the given options there is no option matches this answer. So for this problem, no answer. The next question here is: an isolated generator not connected to infinite bus is excited to produce rated voltage on open circuit. If the field current is kept unaltered when load of 0.8 lead is increased, identify the variation of terminal voltage with the load current. So here we are having an alternator which is separately excited. So alternator field winding here. So here we have alternator. Excitation is kept constant. So this is kept constant here. Now in this case, if you draw the curves of the armature current and rated voltage, so this is ZPF lag and this is UPF and this is 0.8 lead and this one is ZPF lead. So the variation of the current here is, as the current increases, terminal voltage increases because of this excitation kept constant. So the appropriate answer here is B. The next question here is: the per phase induced EMF of an alternator has an expression E is equal to, so E is equal to 10 sine omega t plus, so 2 cos 3 omega t plus theta. I can write it as minus 2 sine of 3 omega t. So we get maximum value at omega t is equal to 90 degrees. So E is equal to 10 sine 90 minus 2 sine 3 into 90. So this is nothing but 10 into 1. So minus 2 into minus 1. This is equal to 12 volts. This is the answer. The next question: a 3.3 kV 400 volt single phase transformer required 330 volts to allow a full load current at 5 SE is equal to 75 degrees. The voltage regulation at full load 0.707 lagging is. So here the percentage regulation is equal to VSE divided by E2 into cos theta SE minus theta 2. So theta SE already given and we need theta 2 here. So theta 2 is a unknown thing here. So we can find this from the given data. So cos theta 2 is equal to 0.707. So theta 2 is equal to 45 degrees. So from this, so this is equal to VSC is nothing but short circuit voltage. This is 330 volts divided by the voltage here we are having 400 volts. So 400 into cos 75 minus 35. So this is equal to 45 here. So 330 divided by 400 into cos 30. So we will get 0.8666 here. Okay, in percentage we can say 8.66% here. So this is the answer. The next question here is the conductor of a 10 km long single phase two wire line is separated by distance of 1.5 meters. The diameter of each conductor is 1 centimeter. If the conductor are of copper, then the inductance of the circuit is. So inductance per phase is equal to mu naught mu r by pi into 1 by 4 plus natural logarithm of d by r. So into length. So this is a inductance formula. So mu r relative permeability for air is 1. So this is equal to 4 pi into 10 power minus 7 into length is 10 kilometers. So 10 into 10 power 3, in which I am converting into meters, divided by pi into 0.25 plus logarithm of d. So distance between the conductor is 1.5 meters. It can be written as 150 centimeters. So 150 centimeters divided by, and here the given is each conductor diameter. I want radius. So radius means 0.5 is the radius. So this is the diameter, this is the radius. So 0.5 centimeters. So if we solve this, we get the answer as 23.8 millihenry. The option here is D. The next question, given two speed time curves A and B, the comparison of specific energy consumption is SEA, that is this one, and SEB is this one. Okay, so speed time characteristics. A and B both having similar acceleration as well as similar retardation characteristics, but the different maximum speeds. So in this case, the SEA, specific energy consumption of A machine A, is nothing but specific energy consumption of B. So D is the right answer. The next question here is the unit of luminous flux. So unit of luminous flux is lumen per meter square. The option is A. The next question here is the tractive effort exerted by locomotive while hauling a train on a level track at 74.6 kilometers per hour is 36,000 newtons. The horsepower output from the locomotive is. So formula here is the output power of driving wheel P is equal to force into velocity. So this is nothing but 36,000 into velocity is 74.6 kilometer per hour. This is equal to 36,000 into 74.6 into kilometers means I will convert it to meters, 1000 per hour means I will convert into seconds, 36,000. So 3600. Okay, so 1, and here we get 100. So 746,000 means kilowatts. Okay, so 1 HP is equal to 0.746 kilowatts. So we can convert this one as 1000 HP. The answer is D. The next question, the building measuring 30 meters into 30 meters is to be floodlight on front side with a brightness 25 lumens per square meter. Coefficient of reflection of building surface is 0.25. The lamp of 500 watt having a lumen output of 8000 each is to be used. The number of lamps required. So number of lumen required is equal to illumination into area into waste light factor divided by maintenance factor. So here we have to make certain assumptions that the waste light factor is 1.2 for regular surface and maintenance factor is 0.75 for regular surface. And in this case, the illumination E is given in 25 lumens per square meters, and we convert into lumens per meter square, so that what we'll do is, so 25 divided by 0.25, this is because of building surface coefficient, so it will give us 100 lumens per meter square. So this is equal to, so 100 into area is 30 meters into 20 meters, that is 600 meters, into waste light factor is 1.2 divided by 0.75, it will give 96,000 lumens per meter square. Next thing is, the lumen produced by one lamp is equal to output of the lumen of each lamp. So next one is, I'll take lumen produced by one lamp is equal to output lumen of each lamp into beam factor. So here the beam factor generally we consider it as 0.6. This is equal to 8000 into 0.6. It is nothing but 4800. Okay, so now the number of lamps required is equal to number of lumens required, that is this one. So number of lumen required divided by number of lumens produced by one lamp. This is nothing but 9600 divided by 4800 is nothing but 20 lamps. So 20 lamps are required. And the last question here is, in dielectric heating, if the distance between the electrodes is equal to half the wavelength at given frequency, then the material will not be uniformly heated. So this is the option. So thank you friends, thank you for watching my videos and your comments and subscriptions. Thank you. Have a nice day.